Hello everyone, this is me Shuhab, and in this video I will show you how to perform an open circuit test or no load test in a transformer. So in the transformer we know there is two types of test or experiment we do. One is open circuit test or no load test, and another one is short circuit test or full load test. And why we do so? Because to get the loss components. We measure two types of losses, like one core loss component, and second one is copper loss component. So in this video we will try to find out this core loss component by doing this in circuit or no load test. So first of all, let me draw the circuit diagram. Like this is the primary side, this is the core, and this is the secondary side. And in the primary side we have to take the winding component, like this resistance, this reactance, and the core component, like this core component, core loss component, and this is the magnetization component. Okay, this is all about the primary side. So in the primary side we will enter a voltage, let's say Vs, and we have to keep the secondary side open. Why we should keep the secondary side open? Because when the experiment will be performed, then there will be current flow in the primary side, let's say Is, and our target is to flow all of the Is current to the magnetic side. That means we have to make sure that Is should be I not completely, and there should be no I2 prime current. Okay, so if we want to eliminate this I2 prime current, we have to eliminate this I2, because this I2 prime is coming for the I2 only. So I2 prime is equal to minus negative and negative I2. So if we want to eliminate this I2 prime, we have to eliminate this I2, and for this reason we have to keep the secondary side open. So whatever current will be taken from the input side Is will completely be I naught. So Is will be I not completely, and this is our target to make. And secondly, we have primary side and secondary side, but in the transformer we have also two sides, like high voltage side or low voltage side and high voltage side. So which side should be primary and secondary? Look, when we try to get this core loss component, we have to think about the core only. So in this core, our target is to make the magnetic flux at its peak point. I mean, we have to maximize the magnetic flux phi. So this phi is related to the supply voltage Vs, not with the current. So our target is to make the supply voltage at rated point. So in which side it is easy to make the rated voltage? In low voltage side or at the high voltage side? Obviously in the low voltage side. So we have to make sure that the supply voltage should be rated, and in the low voltage side it is easy to make the rated voltage. So primary side will be low voltage side or LT side, and we should make the high voltage side or AC side secondary, and we have to keep this side open. And in the other hand, in the high voltage side, making rated voltage is very much difficult, and it is dangerous to handle. So this is all about the circuit. Let's Now we have to add the uh, measuring element, measuring devices. So first of all, we have to measure the voltage, supply voltage, with a voltmeter. Then we have to measure the current flowing inside of the circuit with the ammeter, and then you can measure the power with a wattmeter. So which three things we are getting? First of all, supply voltage, then input current, and then the power. Okay, so we will get the numerical values from the reading, but if we write the equation, then W is equal to Vs Is cos theta. This is the power factor angle theta, we know. And here you can see that this supply voltage Vs will be applied in between this point, because we are not considering these parts, so the voltage drop across these points will be 0, okay, or negligible. So this is or I naught will be divided into two components, like one is magnetization component Im and another one is Iw. So this Iw is reason for this core loss component mainly, and this one makes the flux, and this is not take actually the real power. So if we have these values, then we can get this power factor easily, because we know we have measured this supply voltage with voltmeter. We have the supply current Is with the ammeter, and we have the real power with the power meter or wattmeter. Then cos theta will be this, W divided by Vs Is. Then we have the current, real current or loss current of Iw is Is cos theta. Okay, you can say this one is the loss component current Iw. And then if we have this, okay, this current, we can have this resistance, because the supply voltage is Vs across this point. So R equal to Vs divided by Iw. Quite easy, right? Then if we have this Iw or this Is, then we can get easily I naught by, sorry, we can get this Im easily, like Im equal to I naught square minus Iw square, or Im is equal to Is sin theta. Okay, then if we have Im and the supply voltage, then we can also have this X naught. Okay, let's say it's a X naught. This reactance has the reactance X naught. So X naught will be Vs divided by Im. So we have this component like Rx, and if we try to find out the Z, that means the total impedance, then we can get it easily, like R square plus X naught square. So this is the thing that we have to do in this open circuit test or no load test. We have this power factor. We have this power factor. We also have the core loss component R. We have the magnetization reactance X naught, and we have the total impedance. So if we make the experiment like this, we can get easily our intended results. So this is it for now. Thank you, and see you in the next video.